Hello, grade 12, and welcome back to Maski TV and Maski Miller Learning. We are here again to assist you and make sure that you do what you have to do as you prepare for your trial examination. So let's hit the ground. Today we are focusing on differential calculus, which is the topic that has quite a lot of marks in paper 1. So we're going to do some practical questions, but just before you go there, remember that you need to understand and know the limit and the derivative of any given functions, as well as how to use the first principle, which they call it the definition of differentiation. So you just have to try and balance the language as well. The use of differential rules, as well as solving many types of examinations. How to do it, which one is difficult, what is it that I can't do. Okay, so your cornerstone of all this is this particular function. So if you have to deal with any question that has to do with differential calculus, you need to know and understand this formula, which is called first principle. You always have to know and understand it and remember how the limit is written and what it is that you have to do. So we will go through that together. Okay. In all this, what we are doing, we always look at the errors that has been done and some common mistakes by your friends and any other one who have once write the exams. So some of the examples that we have put there, taken from the diagnostic report, that learners do forget the fact that the limit has to be written in a particular way for first principle. You have seen, for example, then in the first principle that the limit is written right after the equal sign, not before. So always when you are copying down this formula, make sure that you adhere to this particular structure, because if you write the limit before the equal sign, then the answer will be incorrect or the statement is already incorrect, right? The next one is when you drop the constant incorrectly. What is that? What do we mean? So we're saying that whenever you are doing any of the derivative or using a formula or even using the rules, you should not look at the constant as if it has to be derived. For example, if you had f of x, it's equals to 2x to the exponent 3. Or that is one of the examples. So when you derive, you do not look at 2, you only just look at x to the exponent 3. That is one of the examples. Another example is if when you are given f of x equals to a half and it has an x, for example. So that half, it's a constant value. Please do not derive it. Leave it like that, because that is how it has to look like. So please always try to separate the terms so that you can be able to talk to what you have to derive. Always derive the variable that it is asked for you as you respond. Some you forget to apply the rule when we have separate terms. So that example will be if you are given, for example, a function that has 2x squared minus 3, for example. So when you derive, remember that you must derive each and every term by itself. So if you derive only 2x to the exponent 2, and you leave out the negative 3, you automatically have lost the mark, right? So please remember that every time when you are deriving, you focus on each and every term. All right. Okay. Now I'm going to show you an example that have been created for us from a previous, from our textbook, which is Classroom Mathematics. We have the book and you can be able to shop it online. Just going to show you the color of, this is how the book look like. So you can get most of the question from this book as well. And you can also see it there. You can shop it online or you can buy it in any store. So this is what we have. So let's do it together so that you can be able to follow on what happened and how you're going to respond to the question. So here they say, use the definition of derivative, which is known as first principle, to find the derivative of f of x equals half x squared. Remember, I just said to you now that whenever you see something like this, the half is just a particular constant that we have. You do not have to do anything to it unless you are just busy finalizing your answer, right? So when you have this, always what I tell my children is write down the formula right from start. From the word go, copy down your formula. So that is the first derivative of x equals, right? Remember that the limit as h approaches 0 of f of x plus h minus f of x all divided by h. You see, so you have to write it the way it is. You cannot do it otherwise. So that's the first thing. Then the next thing that I ask them to do is to make sure that when they write the f of x, they also write the f of x plus h right from start. So in this case, our f of x plus h will then be equals to, then what you do is, in this case, everywhere where you see x from the given function or from the given f of x, you just make sure that you substitute x plus h. So you're going to replace your x by x plus h. So that is what actually this formula says. So this is our x there. Then now we must replace it with x plus h. Make sure you do it like that. So when we do that here, we're going to leave our half, which is 1 over 2, since we are not really touching it. And then where there is x, we are going to put x plus h, and then we square that. In context, this will give us a half, and then we have x plus h multiplied by x plus h. Always just make sure that you write that first and you deal with it until you get to the answer. That will then be equals to a half, and then you multiply out, or you multiply out to remove the bracket. You expand, right? So x multiplied by x will give us x squared. X multiplied by h will give us a plus xh, while h multiplied by x will also give us what? Will also give us xh, while the h multiplied by h will then give us h squared. Then we move from there. We then look for the like terms. So let's do that. We have our half, and our like terms is xh and xh. So when we add them together, we get 2xh plus h squared. Just like that. So this is what we are going to have, or what it is that we have in terms of our f of x plus h. So every time you see it like that, try to work on a side way, and then you come back to your equation and then you fill it in. If you write it on a side, you can actually just put a small highlighter, or you can just say, this is what I need to know, or this is what I have to use. So this is your umbrella of what you are going to put into the formula, right? So you already have the f of x. You now have calculated your f of x plus h. So let's substitute. This will be equals to the limit as h approaches 0. That is very, very important. Then instead of writing f of x plus h, we are going to write, let's use our green. We are going to write a half, and then it has x squared plus 2xh plus h squared. That is what we have, right? And then we subtract that with, let's do this. We subtract that with the f of x, which f of x is given as a half x squared. Then we divide the whole of this by h, just as it is on the formula, and that's how you answer that question, or you write it in that second step. Then as we go on, that will be equals to the limit as h approaches 0. Then you start multiplying in so that we can see what we have to do. So we have a half x squared, because we are now removing the bracket, and then we're going to have plus. So a half multiplied by 2 will give us 1. So we're going to remain with xh. Again, a half multiplied by h squared will then give us plus a half h squared. But remember, we have minus f of x, okay? So we're going to say minus a half x squared and then divide all this by h. Just make sure that when you divide, you do not divide through the limit as h approaches 0, okay? You only divide the other side and then we move like that. So let's check, do we have like terms? Yes, we do. This is a like term with this part. If you look at them properly, you would see that those two are like terms. And if we do our magic of maths, we will then be able to see that those are going to give us 0. So that will be equals to the limit as h approaches 0. And then we can just quickly write what we have is xh plus half h squared, all divided by h. Then after this, you can see that we do have some common factors, which is h. So we can take out the common factor, which then we have a limit as h approaches 0. When we take out the h, we're going to remain with x plus a half multiplied by h, and then we divide that by another h, which is on the denominator. So you can see that this divides and we'll end up with 1. And after doing that, we can then have what is remaining. It equals the limit as h approaches 0 of x plus 1 over 2h. Right, when you are here, you do not really substitute by 0 because this simply means that the value of h is approaching, going very close and closer to 0. But it's not 0. But since we don't know what it is, we then reach this point and just write our answer to be x. In your brain, you will have to be substituting the 0 because everything multiplied by 0 is 0. So since it's very, very near 0, we then approach that way. But please do not show that you are actually replacing with the 0, although we are doing it to get to the solution, which is what we have right now. All right. So this is what has happened into this statement, and that's what happened. You can see that quite a lot of steps are not shown, but this is what we use then to explain and teach for you to understand. Okay, did you master that? I hope you did, because this is how you get to the question. So when we are done with that, or if this is what you have understand, I have then went and get a few question papers that you will have to use to practice. If you need more of these question papers, you can actually go to our Maski WhatsApp, which is your friend, and you ask for the previous question paper. Maski will always give you the previous question papers, or you can just go to the DBE website and then you can download the previous question papers that are legit and you can be able to use them. Okay, so I went and get our 2022 November and our 2023 November with some example of what it is that you need to know. So if you check here, for example, you will see that they are asking similar question of what we have, but this one has now a binomial, and then this one have still a monomial but with a negative. So yours is just to ensure that you understand what you need to do and how you need to do it. So it's the same. If they ask you to use first principle on the definition to answer the question or to determine the first derivative, what you do is you just copy the formula first. That is your first rule. Copy your formula first, and then you make sure that you have the formula. Remember, equal sign comes before the limit. So that is equals the limit as h approaches 0 of, then you write f of x plus h minus f of x, all divided by h. So that is the formula we are talking about. And as I give you 2 seconds to write it down, wrap it up, I will be waiting right for you to make sure that you get to the answer. Okay. All right, I hope that you guys have got to this. So let's see. Do it together, as I know that most of you have got it properly already. So, but remember, the rules still stays, or the idea that we are using still stays. Before I do anything, I'm trying to say what it is that can be f of x. So I am given f of x to be equals to x squared plus x. So now I know that I am going to substitute that to my f of x. Again, I need to know what is f of x plus h. So I am going to then substitute wherever I see x with x plus h. So let's do that. I have x plus h squared plus, and then I have my other x plus h. So that is what I mean when I say every time you see x, you replace it or you substitute x plus h. Then we go on and then we simplify, open our two brackets, multiply it out, do whatever we can to end up with one statement. So here we have x plus h and another x plus h. But remember, there's a plus x plus h. For now, let's leave it like that and we'll remove it together when we remove the bracket. Okay, let's multiply through. X times x will give us x squared. X times h will give us xh. And another x times h times x will give us xh, which tend to be 2xh. Literally, it's similar to what we just have done on the other side. And as we go, you will see the pattern of what is happening there. Then we have h squared when we multiply h and h. Then we can now remove the bracket. We have x and then we have h. So that is what we have at this point. Then after here, we can then substitute into our formula. So let's do that. Remember, this is our formula. So we are going to substitute this all inside our formula for us to get it right. So the first derivative of x will be equals to the limit as h approaches 0, and then we substitute. We said we have x squared plus 2xh plus h squared plus x plus h. So that is what we have. And then for f of x, we're going to say minus. Remember, there is a minus that is coming with the formula. So we have to put that minus and then we put everything inside the bracket. Provided you have any other value, you have to try and put the bracket so that whenever they give you a value or a function with a negative, you'll be able to remember to multiply. So let's put it in there and then we then divide by h, right? As it's all divided by h. All right. Okay, let's move on. Then we're going to have the limit as h approaches 0. Then we start removing all the brackets. So let's do that. We have x squared plus 2xh plus h squared plus x plus h. Now we can deal with the minus. Then it's minus x squared minus x. And this all is divided by h. Right, so let's see if we have some sort of like terms that we can deal with, which is literally always have to be the case. If you don't have some like terms, you did something wrong somewhere. So please pay attention to that. So this x squared and the negative x squared, they are like terms. They are going to give us a 0. Again, we have another one. If you check properly, you will see that we have x, which is positive, and a negative x, which the two of them must give us a 0 as we subtract, right? So then it means we will remain with the limit sh approaches 0, and we just copy the rest of which are not like terms, which is 2xh plus h squared plus h, then we divide it by h. All right. Now, when you reach this point is where you must be able to see some sort of common factors that you have to take out. So we're going to have the limit sh approaches 0. Then we take out the common factor, which is h. Then we remain with 2x plus h plus 1. Then we divide all that by h. The h that is outside with the h at the denominator will then divide for us to have 1. So let's copy what is remaining. We have the limit sh approaches 0 of 2x plus h plus 1. Usually we just put them under a particular bracket so that we can be able to remember that this is one thing altogether. So all the time when you reach this space, any value that or any h that you still see at this point, we tend to make it a 0, because we are saying that h is approaching 0. So as a goes very, very near to 0, we then use that 0 to substitute the h, but we do not show that we are substituting. So every time you reach the stage where you still have h at some point, you cannot do it on this step, for example, where we have cancelled, because the moment I put 0 as h, that will make the whole statement undefined. So that is why we don't substitute or put the 0 right as we come, or think of a 0 at any case until we come here. So there we are now substituting that 0. So the moment you try to substitute the 0 or you eliminate the h, also the limit goes with it. So therefore our answer will be 2x plus 1. So that is how you tend to get to the solution. All right. I hope you guys have understood that, and you will be able to go through this and be able to write it properly. I mean, as many times you do this, when you are practicing, you will end up not having to do this, which we are doing here at the top, because you will then be a master of this. But as you are practicing, please try to do them separate, and then you substitute. It will save your time. Remember, this question has 5 marks, which in my opinion, these are free 5 marks. You can take them, right? Okay. So let's do the next one, which is literally the last one. So you can see how they do it. They just differ there and there. Either one, they put 2 binomials. Sometimes they'll put trinomials. Sometimes they put a fraction. Sometimes they put a negative before the coefficient, and. So you just have to try and make sure that you understand what you are going through. Okay, let's do the second one for 2023. We are given f of x. So let's write it. F of x equals a negative 4x squared. Remember that the negative 4 is what we have, and it's very important for us to stay with the negative until we are at the end. Okay, so when we want to do this, as always, let's write down our formula. F of x, the first principle formula, that's what we mean. So it's equals to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So that is our formula, and then we can start doing our own things, which is what we like the most, right? Let's write f of x plus h so that it does not disturb us as we go. So f of x plus h will be equals to a negative 4 must stay as a negative 4. There's nothing we can do to that, but whatever that is x, it's now going to become x plus h. Okay. So that is how you write it. It has a square. Please remember that. And then that is equals to a negative 4. let's open two brackets of the same context. So it is identical, two brackets. Okay. Now after that, we can then remove our brackets. So we have negative 4. When you multiply, this is the pattern I was telling you. When you multiply these two, always they will give you this. But please try to multiply it out so that you can get it. So it's x times x, x squared, x times h, x, h times x, x, h. Then the two of them will give us 2xh. Then we add our h squared because h times h will give us h squared. You can right away just remove the brackets and you have as negative 4x squared minus 8xh minus 4h squared. Then when you have this, then you can go to your formula and then you substitute. So let's do that. Okay. When we substitute, remember this is our formula. When we substitute, we're going to have the first derivative equals the limit as h approaches 0. So let's go. Instead of writing f of x plus h, we're going to write this statement here. So that's negative 4x squared minus 8xh minus 4h squared. That is only for our f of x plus h. We still have our f of x. So we're going to minus this, and then in a bracket, we're going to write the f of x as it's given to us, a negative 4x squared. Please, please, please remember to do it that way so that you don't make any mistake. Divide it by the whole h like that. Okay. Then we can now do our things, which is to simplify. So that's the limit as h approaches 0. Then we have negative 4x squared minus 8xh minus 4h squared plus 4x squared divide by h. It is plus because a negative times a negative will always give us a positive. Now, do we have any like terms? Yes, of course we do. So that will be the like term with this. So can you see? A 4x squared has a negative 4x squared and a positive 4x squared, which will then give us a 0. Then we have a limit as h approaches 0 of a negative 8xh minus 4h squared. Divide the whole thing by h. Then we can now take out the common factor of h. So that is the limit as h approaches 0. Then let's take out our common factor h. We remain with negative 8x minus plus, minus. So we leave our minus there. So that is a negative 8x minus 4h, since we have taken one h out, and then we divide both or all by h. Can you see that pattern I spoke about, that you need to be able to take out h in all the terms? So we divide and we left with what we left with there. So let's copy it down. Our remaining is the limit as h approaches 0 of a negative 8x minus 4h. As I said, when we reach this step whereby h is no longer in the denominator, then what we do is we are saying as h approaches 0, whatever that has h, it acts as if it's substituted by 0, but not really. So we're not showing that steps, but we are literally saying that xh is now approaching 0. So then the answer will be negative 8x. Okay. These 5 marks cannot just pass you like that. You guys should be able to get that 5 marks right just like that. But then if you have any question, anything that you need us to assist with, before we move on, you need just to drop it on the chat or anyhow that you think possibly to get to it, because it does look easy, but trust me, during the examination, it does dribble you quite a lot. Okay. Now, With all this, what I like about maths, my story of life, is even if there's a longest way to do things, there's always the short way, right? So this is the other way to do derivative, but that is if they did not tell you use first principle. If they say use first principle, then you must use the first principle, unfortunately. But if they did not say, we can then use the derivative rules or differential rule, right? So we have the differentiation rule, which I always just like using the normal thing that we have, right? For example, if you were given f of x equals x, let's say 2x to the exponent 3, something like that. If you are given this as an example, then you can be able to then apply the rule that we have, which is our one and only rule at this point that you're going to use, which is the one that shows that if ever I am given an a and an x as a base and an exponent of n, when I'm deriving, or the term that I derive, what I need to do is drop my n value, and also at my exponent part subtract by 1. So I'm going to show you what it does to this particular example here. So what we are saying here is that if I have f of x equals to 2x cubed, what I do the moment they say I'm deriving, which is one of the representation can be that, I will always just write it this way. So let's do this so we can open the room for it. So what happened is we are going to drop according to them. We're going to drop. So let's drop our 3, right? That is the 3 that we have. But even though we are dropping the 3, we also need to subtract 1. Right, so that is what the rule says. You're dropping the 3 and then you subtract the 1 as it shows there. So you always have to remember that the 3 that I have here, it is the one that has come here, but I'm multiplying with that. It's not just something that is different from that. Okay, so if I have it that way, what I'm going to do is then just multiply and just do the math. So it's 2 times 3, which is now going to give me a 6, and I'll keep my x, but then 3 minus 1 will be 2. So instead of us having 2x cubed, when we derive it, it gives us 6x squared. So that is actually the example of what you can do. But another thing that you can do is, if you check on the questions that we had, which is this ones, we can use the same principle or the same rule. So for example, with the question that is question number 2, or the one for 2023, this one, if you check that, we can do the same thing. Let's see, let me show you. If you have f of x equals negative 4x squared, that is what we were given. When I use the rule that is given to us, it's actually going to follow the same principle. So let's do it. The derivative, the moment I do that, then the magic should run. So I have my 4 and I have my x. Then what is happening here is that I'm going to multiply this by 2 and also subtract 1. Right? So that is what I am doing. But remember, there's a minus there. So that is what we have there. So what is going to happen now? We just do the maths. A negative 4 times 2 will give me a negative 8, right? So x to the exponent 2 minus 1 will just give me a 1, which we can write it as negative 8x, like that. If you go just 2 steps back, you will be able to see that the same answer I'm talking about now is the same one I got when I use the short way, or when I use the formula, right, which is the rule that we have. So please bear in mind, and you know what I do is, every time they say I must use first principle, I actually check by using the rule to see if what it is that I'm going to find with first principle, it's exactly what I will find with the rule. That's a tip. Okay, so you can also do that to check what it is that you have. So that is the example of what we have. So again, if you check the second one which we have there, let's see, we had f of x, This doesn't look nice. Let's use white. So we have f of x equals x squared plus x, right? So if we follow the similar rule, when we derive here, you will see that if ever you are following what I've showed you right now, you'll be able to see, I'm just opening it up so that we can be able to write. You'll be able to see that this will have a 1, which is always there, but then it will be multiplied by the 2, and we'll have 2 minus 1. Again, on the other side, remember each and every variable or everything, literally, it has the power of 1. So that means we're going to have 1 times 1, and then here we had 1 minus 1, because there was 1 there already. So that's what you do. So let's do the math. 1 times 2 will be 2, and x will remain. 2 minus 1 will be 1, which I'm saying we don't really have to write, but for now, let's put it there. Then the next part, which is plus, remember we are saying that it has to show that if you have two things, you derive them separately like this. So you need to ensure that the derivative of your two terms that are given are as well derived separately like this formula is showing there. So make sure that you do it in that format. So that's what we are doing. We have done the first part of derivative, and we need to also do the second part of it. Okay, so let's do the second one. We said 1 times 1 will still give us 1, but then x will have then x to the exponent 1 minus 1, which is x to the exponent 0. So that means that we'll have 2x as our answer, which is going to give us 2x plus 1. So that is 2x plus 1, right? Because this is 2x to the exponent 1, which is 2x, and then x to the exponent 0 equals to 1. So 1 times 1 will give us 1. The same thing that you have here. If you go back to the question that we did, you'll be able to see that that was the answer that we got. Let's see. So this is the answer we got, 2x plus 1. So do you see that it's actually just another way, or literally a shortcut to get to what you want? So you can use either one of these methods that we have. So this is the examples that we have, and we have used them like that. So you can have it as a plus or as a minus. So you just have to make sure that you look at what you have and make sure that you treat them as equal as possible. Then we have one more that we have not done, the constant one. Whenever they give you a constant to derive, so say for example, you were given that y is equals to 3, right? And they want you to derive that. What is literally happening here is that I have y equals 3. Somehow I do have x, right, to the exponent 0. But we are not writing that because x to the exponent 0 is 1. We don't write that. So when I derive this, if ever I have to derive, remember I said there's many notations. I can actually write y with a dash there to derive, or I can actually write d over dx, or I can write dy over dx. So there's many notations. The moment I do this, what I'm saying is I'm going to say 3 multiplied by the 0, and I have x 0 minus 1. So that is what I'm actually having, as if I derive that. But everything that is multiplied by 0 is literally going to give us 0. So what does this mean? A derivative of a constant value is always equals to 0. Okay, so that is one of the things. So there is an example that we have shown. You can see what happened there if I use the method that we have done, which is the derivative rule. If I use that differential rule to this equation, let's quickly do that. So that is exponent 3. Let's quickly do that. Minus 2x squared plus 5. Remember, we must look at them in a separate format. So the moment I say I am deriving like this, it's me saying I'm deriving. I need to look at them individually. So what I'm going to do is I'm going to have 3 multiplied by the 3 that is at the exponent. Then x to the exponent 3 minus 1. Same applies to the rest. I'm going to have minus 2 multiply by 2x to the exponent 2 minus 1, like that. And then remember we said that the derivative of the constant always have an x with an exponent 0, okay? So what we are literally saying there is that we're going to have 5 multiplied by 0, and then we have x to the exponent 0 minus 1. So that is what we have, right? Like that. So then we're going to have our answer as 3 times 3, that is 9, and then we have x squared. Then we have our minus 2 times 2, it's 4, and then we have x. Remember, everything that we multiply by 0 will give us 0, so we're going to ignore that, and then we move on. So you see how this was done and how you get to the solution. Since we are trying to get this done, just for a summary, every time you are deriving, this is what you need, provided that you are using the rule or you are using the principle. So you can find any of this. For example, they can give you any quadratic which is either trinomial. They can actually give you over and above quadratic, especially when you're dealing with the rule, right? They can say to the exponent 5 and so on, as well as they can give you a binomial, just like that. You have seen that we have done that, and as well as this one, you can see this is where we had our trinomial quadratic. They can give you another one which is just monomial for you to do either using a formula or you can then use the principle. One important is this one, where I will show you one question that you have to deal with it and you can be able to then solve it. We have already covered this part, so that is fine. So this is how you're going to actually get or recognize what you need to do in terms of that. But before that, a very quick summary that you can find in our X-Kit Achieve page 24, which is our study guide. It does have the rules which shows you what rule are we using and what it is that we are doing. So you can see that here, for example, it shows us a power rule where it shows exactly what I just summarized to you, and also the constant, how it works, and if you have the sum and the difference of any two functions, and if ever you are multiplying by the constant. Very, very important. If ever you see the bracket, eliminate them. Multiply the bracket out for you to be able to derive. Okay? If ever you see a square root, find a way to remove the square root so that you don't have the square root and you can be able to derive. Again, if you see a fraction whereby the denominator is of the variable that we are looking for, please try to eliminate it as well, but you don't just take and throw, you use the proper maths way to get it up. Like here we had 3x squared, but now we had 3x to the exponent negative 2. So that is what you do when you deal with these questions. A very nice example, which you can also find in the same page, which explain to you what are you doing, what is happening, and how you get to the answer. One thing that I wanted to show you with the first one is if you are given y equals x squared minus 2x plus 4 divide by x. Always, before you even try to derive, separate them, right? How do you separate? You will have your x squared divided by x, then you have your 2x divided by x, and then you have your 4 divided by x. As soon as you do this, you'll be able to move to the next step, and then you can derive. Never ever write the derivative before you get your standard form where you can derive. So here we will have x plus x minus 2, not a plus, x minus 2, and then we'll have plus 4x to the negative 1. So you can see that is how the value here has been written, or you can see how we got into the place where we had x minus 2 plus 4x to the exponent of negative 1. So you just do that first, and then after here, you follow the same rules and principle for you to then derive. All the time when you do derivative, most of the time they will ask you to then leave your answer with a positive exponent. So you just have to make sure that you focus only on the variable with its exponent. Either you take it down or you take it up, just like that. Okay, so that same applies to whenever you have some square root. You just make sure that the square root are also multiplied out for you to get the answer. Do not rush. Always when you see the bracket and anything else, make sure that you focus on those brackets and you remove the bracket first, and then you deal with the rest as time goes, as you go down, right? So there's many of the questions that we have. You can find, if you can go to your question paper of 2022, which I've already told you, you can find it from Maski, and also you can find it from the DBE website. The 2023 have very nice question of this, where you can practice what need to be done and how you need to do. Just one more warning, do not be alerted when you see this, because it's just another way of showing the derivative. So by the time you see dx like this, what you do is you go with the dx up until you start deriving, then you drop it. While you are still deriving, when you are still writing the equation or removing the square root or removing anything that has to be removed, you do not drop it. And with this, you must make sure there's always the brackets around that particular question. That same applies to this notation, where you have d divided by dx with a bracket, and then it shows the function inside. You're only going to drop this when you start deriving and you don't write it down. So you're just going to derive and you move on. So most of these questions papers are there for you to literally check and look into them. Work as hard as you can. Keep on asking Maski, and ask us at any time in our socials. And during the session with Maski TV as well, we are able to help you. I hope you guys have understood and you'll be able to grab these marks for the very hanging fruit kind of questions. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.